Good morning, ladies and gentlemen, and I'd like to start off by thanking the organizers of the conference for bringing me into this arena. When Diana wrote to me, she said in my talk I should particularly target the younger scientists, where I look from here and every scientist is a younger one as far as I can make out. I'm going to address this question, which is the one which has been set up for the panel later on. How do we translate scientific knowledge into soil policies and for soil management? And what are the bottlenecks in that process? This is going to be free of data and full of opinion, mainly mine, but I hope we'll be able to progress a bit into some ideas about how to deal with this question. This is a graph, this is the only graph in the talk, which was drawn up by policy researchers, people who study the interface between science and policy, led by Tom Tomich, with whom I worked on many occasions. The y-axis talks about the prominence of the issue, and this is time and cumulative effect. And these are the sort of questions as a problem becomes discussed more and more and enters into the policy arena, the sort of questions that may be posed by policymakers. Is it a problem? Who did it? Who'll have to pay? Will everybody join in and do something about it? It's put in vernacular language. I think Tom is an American after all. And these are some of the responses which scientists will have to make in the green. And I've converted that into a number of questions which I'd like to use in the talk. What is the problem that needs to be addressed? What are the potential solutions to that problem? And what is the biological knowledge that defines the problem? And I take that into the experience which we have in the Tropical Soil Biology and Fertility program, which is a rather specific context in that it's in the tropics, we work with small farmers, and we had the specific target of improving soil management. But nonetheless, it's encased within the soil biodiversity paradigms, starting off with the soil biota and biodiversity, soil biological processes, soil fertility management, our target, but not just for soil fertility, for the range of ecosystem services which are delivered from that. And in doing this, we faced up to the major problem which we all face, which is a complex and total problem of soil degradation. And here it's shown simply in the issue of nutrient depletion. Clearly the soil in front with no fertilizer, the soil behind without are completely different in terms of the way the plant responds. But that soil has lost a great deal of its biodiversity. It is also, the soil structure is gone, the soil organic matter has declined, it's in a very bad state altogether. The problem is there. Is it well enough defined? That's the first question. And what about solutions? Here we come to the biological knowledge. This is a decision tree for selecting organic matter for integrated soil fertility management, and many others that we will use to try and improve soil fertility and the delivery of ecosystem services. So if you've got a properly defined problem, and if you think you've got a solution, you have to move on to the people who manage soil and to the issue of what sort of policies are needed to help implement those solutions. And we're talking initially, and this was the main target of the TSBF program. We're down the bottom here in this hierarchy. in the biological domain with our so-called scientific advice, and we're working with farmers to provide them, hopefully, with better practices for soil management. And what we face then is the farmer's decision about whether to use that or not. And before I move on from this, I should mention that further up, of course, the farmer is not alone when he or her, more likely, comes to make the decision about what to do. They're controlled by community rules, by national agricultural policies, and even possibly influenced by global conventions in some way that neither they nor the scientist knows exist. But as soon as we talk to farmers about soil management, we face problems of adoption of what is being advised. And questions arise. Why is the farmer growing crops? Is it for in cases where we were working with small-scale farmers, is it for subsistence alone, or is there a very strong imperative for profit as well? Is fertilizer affordable if you are recommending fertilizer? Is there if you are recommending integrated soil fertility management, is there organic matter available to use, or is there land available for growing biomass? What communal traditions need to be observed? What are the implications if you are introducing organic management for the increased amount of labor that is involved? And so on, and so on, and so on. And the first thing, coming to issues of policy and recommendation of soil management, is this conclusion, the inevitable conclusion that biological knowledge alone is not enough. The biological knowledge does not define the solution sufficiently, does not define the problem sufficiently, nor does it define the solution completely. There is much more knowledge that is needed. So we move on to another illustration of the same point. This is a diagram drawn up by an economist colleague, and without going into the details that are there, if the problem is over on the right-hand side, and our particular part of it, the loss of soil biodiversity, it is influenced by a huge number of factors of differing scale, of differing importance, delivered by different people. And when you want to influence over on the top left-hand corner those involved in agricultural and land use policies, they are at a very substantial distance from you in terms of the flow of information and knowledge, and they have a very different set of information and knowledge to that which we as scientists have. So that brings me to two further questions to bring the paper to an end, which arise when faced with these issues. What language should we address policymakers with? And finally, who should be involved? Several of these issues have been touched on by other people previously in the conference. With regard to language, avoiding scientific jargon. Our language is impenetrable to other people. Having been retired for 10 years, a great deal of the language of the last week was impenetrable to me. But not only should we try to change how we talk in terms of the use of our own knowledge, we should try and learn the jargon of others, the jargon of economists and policymakers themselves. My second point about language is that dollars speak louder than binomials or biomass. If we can put a value on, and yesterday's session I think was very interesting in terms of this, if we can put a value on what we think is being damaged, then we're much more likely to have an effect. One of the papers which I think influenced me most of all in 30 years of working on soil fertility management, a paper which scarcely mentioned soil at all, and certainly didn't mention soil biodiversity, was by Robert Costanza, an economist, with a group of other economists, which was on valuing the Earth's natural resources and the ecosystem services they delivered. And reading that and hearing that here were people saying what the value of these ecosystem services was something which made me realize very, very clearly just how important it was that what we were dealing with in soil management. And finally in this list, find the right context for delivering our knowledge. And we feel passionate and about soil biodiversity and want people to understand how important it is. But the best way to do that and to get it managed in the proper way may not be to go directly forward with soil biodiversity, but to package it with other things. In the end, the way that soil biodiversity is going to be managed is by ecosystem management, not at an individual population or a species level. So we may need to package what we are targeting ourselves. And at this point, I'm actually going to mention soil biodiversity directly, because in TSBF we did do work on soil biodiversity, and we had a network of sites across all the tropical continents doing a study on the effects of land use change on soil biodiversity, and this was mentioned by Diana yesterday. And part of the product of that we tried to take to policymakers in different ways, and this is a policy brief written by the Indian team in that project, and Professor Rao is here in the audience. And it was written to go to the United Nations Education, Scientific and Cultural Organization, UNESCO, in India. But it's the title that I wanted to mention here. The title is Linking Conservation of Terrestrial Biodiversity with Climate Change Mitigation and the Adaptation and Socio-Economic Development in the Himalaya. Within that, the soil biodiversity impact is mentioned and issues are there, but it's packaged within something which is likely to be more attractive to policymakers. It's at a scale that is much higher than that of soil biodiversity. And it is more likely, perhaps, to have impact with respect to soil biodiversity than a policy paper which addresses soil biodiversity directly. This may not be a popular point of view, but I think it's maybe an effective one. The second thing I'd like to mention on this, which I'm going to touch on in a minute or two, is that it was targeted at UNESCO. UNESCO, of course, is not capable of influencing directly policy in India, but indirectly it has the ear of many people who have direct policy responsibility. And so finding intermediaries to speak for us is an important point. I come to my final question, and if you remember only one thing from this talk, it's what this says. It's not just what you know, but who you know. We have to work with other people if we are going to have any impact of our science, our biological knowledge, on policymakers. We have to work with the farmers and other land users who are the people who have to implement what we wish to be implemented. We need to work with scientists from other disciplines who look at things in different ways and have different components of the problem and different components of the solution to provide. And in particular, we must work with economists and other social scientists in the way that Kate Scow and others were talking about yesterday, to find out the bits of the information which we need, which are missing. And to follow up on my last slide, we need to link with people of influence, champions who can help what we are doing. And we need to do all that to avoid the problem of working on the wrong problem. One of the things which I first learnt when I went and started working with the farmers in Africa was that you could turn up at a farm and say, "I've solved your problem. Here, I have this wonderful management practice." And the farmer would say, "But that's not my problem." That is something we have to avoid. Are we actually talking about the right problem? So in summary, I'd say there's a number of things which I think, from experience of myself and others, that are necessary things to include in any approach to people who will manage the soils we love and who will derive the policies which will control that management. If you are really convinced that what you are doing needs to be taken seriously by people further up the food chain, see it as a policy issue from day one, and always be thinking how your work is going to lead towards some policy change. Define and involve the responsible and affected sectors of the population as early on as possible. Get them on your side. Involve social science and policy expertise. Don't be an arrogant scientist and assume you know all the truth. Define the problem in the terms most likely to appeal: food security, climate change, and so on. Cost the problem and cost the solution as far as it's possible. Provide tools for monitoring and evaluation, not just for posing problems. Find champions. Communicate, but above all, retain and show the passion you have for the subject on which you work. Thank you very much.
Thank you very much, Michael Swift, for this nice views and experiences. Are there any questions? Comments? Yes.
Thanks, Mike, for such an inspiring presentation. I really would like to hear your opinion about, and I know there is no definite answer, but I want to hear your thoughts about this. How to judge during the process of, working with science and farmers and all that we have to deal with. How much or when or how do we need to think locally, and how much nationally, and how much globally, and when to go back?
How long do I have? There's no easy answer, obviously. we have to think locally, because that's where we work. Whatever we do, we're thinking locally, even if we're thinking as wide as a catchment that we're working on, and so on. But the issue, I think, is to keep an eye on the global, if I put it, jump right to the top, on the global part of it. And one of the phrases Tom Tomic and his group used to use when working in Indonesia was local solutions to global problems. And I think by having that, moving backwards and forwards in your mind, then there is the possibility of keeping a realistic view of what you're doing. Helping one farmer, 2 farmers, 20 farmers is wonderful. I mean, it's a tremendous thing to feel that you might have helped. But we are dealing also with a problem that has global dimension. So we have to also try and think of both. And that's yet another reason why we need lots of other people to talk with and involve in the work.